Have you ever looked at a tiny little computer chip, like an ESP32, and then at a big household lamp and wondered, how? How can this little thing possibly control that big thing? I mean, there's a huge power difference, and if you just connected them directly, you'd fry the chip instantly. Well, today, we're going to show you exactly how to bridge that gap safely.
So what's the secret? How do we use a teeny tiny low voltage signal from our microcontroller to safely switch on and off a high voltage device? The answer, it turns out, is simpler than you might think. And it all comes down to one key component. And the hero of our story is this little guy, the relay. The best way to think about it is as an electronically operated switch. It's kind of like a translator or a bodyguard, letting our tiny ESP32 safely boss around things in the big leagues of electrical power. So what a relay does is use a small electrical signal to control a completely separate high-power circuit. The crucial part here is that there's no direct electrical connection between the two sides. They're isolated. It's kind of like you're sending a text message to a giant robot to go and flip a huge power switch for you. You're giving the command, but you're a safe distance away.
Now, relays basically come in two main flavors. The one you'll use most of the time is called normally open, or NO. All that means is that by default, the high voltage circuit is broken. It's off. When our ESP32 sends a signal, the relay closes that circuit and turns the device on. Normally closed, or NC, is just the opposite. The circuit is on by default, and sending a signal actually opens it up to turn the device off. For our lamp project, we're definitely going to use normally open.
All right, enough talk. Let's get our hands dirty. First things first, we're going to connect the low voltage side of the relay to our ESP32. This is great because it lets us test all our wiring and code before we even think about introducing high voltage. Safety first.
The wiring here is super straightforward. The ground pin on the relay, which is usually marked with a little minus sign, just connects to any ground or GND pin on the ESP32. VCC is the power for the relay module itself, so that goes to the 5-volt pin. And finally, the signal pin, sometimes marked with an S, is how we actually control it. We'll connect that to a digital pin. Let's use GPIO 2 for this. And that's it. The low voltage side is all wired up. So, we've got it wired, but we're obviously not plugging in the lamp yet. So, how can we actually test our setup? How do we know for sure that our code and our wiring are correct before we mess with the dangerous stuff? But luckily for us, most of these relay modules have a handy little LED built right onto the board. This light turns on whenever the relay is activated and turns off when it's deactivated. It's the perfect and perfectly safe way to test our entire setup. And the code for this test? It's about as simple as it gets. First, we just tell the ESP32 which pin we're using, pin 2. Then we set that pin to be an output. In our main loop, digital write relay pin high sends the on signal. We wait for 2 seconds. And then digital write relay pin low sends the off signal. It's pretty much the classic blink sketch, but instead of a tiny LED, it's for our relay. Okay, go ahead and upload that code to your ESP32. If everything's right, you should see that little LED on the relay module start blinking. On for 2 seconds, then off for 2 seconds. You'll also hear a really satisfying click sound from the relay itself. That click, that's the sound of success. It means our low voltage side is working perfectly. So our test was a complete success. The code is solid, the wiring is correct. Now it's time for the main event, connecting and controlling a real high voltage household lamp. Now before we go any further, I have to be extremely clear here. You are about to work with high voltage from a wall outlet. This stuff can cause serious injury or even death. Please be incredibly careful. If you are not 100% comfortable with what you're doing, please do not proceed. Your safety is the absolute top priority.
Okay, first, and I cannot say this enough, unplug the lamp from the wall. Go and double check that it's unplugged. Now, you can carefully cut just one of the 2 wires in the lamp's power cord. It doesn't matter which one. You'll take one of those cut ends and connect it to the relay's middle terminal, which is called common, or C. Then, you take the other cut end and connect it to the NO, or normally open terminal.
And that's actually it. You can now plug the lamp back in. Using that very same blinking code from before, when the ESP32 sends a high signal, the relay will click, that normally open circuit will close, and boom, your lamp turns on. 2 seconds later, it turns off. You are now controlling a real-world appliance with your microcontroller. How cool is that?
So a blinking lamp is cool, but it's not super practical, right? So let's take this to the next level. Instead of just running a pre-programmed loop, we're going to give our ESP32 the power to listen for commands that we type on our computer. We'll do this using something called the serial monitor.
To get started, we have to open up a line of communication. This one line of code, serial.begin115200, basically tells the ESP32 to start listening for messages coming from our computer at a specific speed. You can think of it like tuning two walkie-talkies to the exact same channel. So now, inside our main code loop, the ESP32 is constantly checking, just asking over and over, is there a message for me? Anything new? The moment it sees that a message has arrived, it reads the whole thing and stores it in a variable that we'll just call CMD, short for command.
And here's where the magic really happens. The code just looks at that CMD variable and asks a simple question. Does this variable equal the word on? If the answer is yes, it sends the high signal to our relay pin, which turns the lamp on. And right after that, it checks for the other possibility. Okay, what if the command is off? If it sees that, it just does the opposite and sends the low signal to the relay to turn the lamp off. It's really that simple to create an interactive on-off switch.
Oh, and one last, really crucial tip here. In your Arduino programming software, when you open the serial monitor window, you have to make sure that the little drop-down menu for the speed, the baud rate, is set to the exact same number we used in our code, 115200. If they don't match, the computer and the ESP32 won't be able to understand each other.
And there you have it. We went from a simple blinking light to controlling a real lamp just by typing commands. You now know how a simple, inexpensive relay can safely bridge that massive gap between our tiny microcontrollers and all the high-power devices in our homes. And this same exact principle works for a fan, a coffee maker, your holiday lights, pretty much anything you can plug into a wall. The possibilities are huge. So the only question left is, what will you power next?